So again, iodine being added to the precursor molecule, thyroglobulin, produces thyroid hormone, or T4, or thyroxine. There's also a secondary thyroid hormone that's produced that's called triiodothyronine, T3, because it has 3 iodine atoms attached to the precursor molecule, is produced in less amount. So we can say that the thyroid follicles in the thyroid gland produce thyroid hormone, even though technically it's thyroid hormones, meaning thyroxine T4 and triiodothyronine T3. And there's indication that there's even a third thyroid hormone. So we can get by with simply saying the thyroid hormone is produced by the thyroid follicles, by the thyroid gland. We can just call it one hormone, thyroid hormone. That's fine. So technically, thyroxine T4 and triiodothyronine T3 are 2 thyroid hormones that are known. So know these terms, etc. But we can simplify it and say thyroid hormone to represent thyroxine and triiodothyronine. So the effect of thyroxine or thyroid hormone on its target cells is to increase their metabolic activity, their metabolic rate, and in doing so increases body temperature. So there's other cells in the thyroid that are called C thyrocytes or parafollicular cells. So these are cells that are found clustered outside of the thyroid follicles. So like cells here, and here, and then in here. So these cells are the C thyrocytes or parafollicular cells, and what they do is they produce and secrete the hormone calcitonin. Hence, C thyrocytes that produce calcitonin. This hormone is released into the blood supply when blood calcium levels are too high. So let's just say you had a meal and you drank a bunch of milk, a bunch of yogurt, a bunch of cheese, and the calcium levels, calcium ion levels in your blood go above normal homeostatic levels. The parafollicular cells, C thyrocytes, secrete calcitonin into the bloodstream, and that helps remove the excess calcitonin from the bloodstream. How? It stimulates osteoblasts to build bone. In other words, remove calcium ion from the bloodstream and store it as calcified bone mineral, and inhibits osteoclasts, slows down the bone digesting cells of osteoclasts. And the activity of, or these two activities help remove the excess calcium that's in your blood, if that was to happen. Another way of thinking about the effect of calcitonin is calcitonin is secreted when you have a ton of calcium in your blood, right? Too much calcium. So you have to have a way of getting rid of it or reducing the blood calcium levels. So it encourages calcium to be stored in bone. The overall effect of calcitonin. Okay? On the posterior side aspect of the thyroid gland, there's clusters, little masses of cells that are referred to as the parathyroid gland or glands. So there's small glands, 4 to 6 on the posterior side of the thyroid, so the back side, posterior aspect of the thyroid gland. And there are parathyroid cells there, also called principal cells, and they secrete parathyroid hormone. Right? Parathyroid hormone secreted by the parathyroid cells of the parathyroid gland. Their effect is to increase blood calcium levels. So low blood calcium levels, so this 2+ here means a calcium ion in the bloodstream. When you have blood calcium levels that are too low, right, below homeostatic levels, that stimulates the parathyroid gland, its parathyroid cells, to secrete parathyroid hormone. And we'll see here what the effects of that are on the body to increase blood calcium levels back up to normal homeostatic levels. There's another type of cell in the parathyroid gland called the oxyphil cells, and the function is kind of unknown, which is always surprising to me that there's still so much stuff we don't know. So you don't need to know function of the oxyphil cells, and I won't even ask you about those. Okay, so blood calcium levels drop below normal. Parathyroid hormone acts to increase blood calcium levels back up to normal homeostatic levels by a number of activities. One, or effects, is stimulating the osteoclast cells to resorb bone, dissolve bone. And by doing so remember osteoclasts resorb, dissolve mineralized bone, releasing calcium back into the bloodstream. So that helps bring blood calcium levels back up. Also, inhibiting the excretion of calcium in the urine. So more calcium is reabsorbed by the kidneys and is able to enter into the bloodstream. Excuse me. Vitamin D also gets converted into calcitriol, an active form of vitamin D. And that will cause an increased intestinal absorption of calcium ion. Anything that might be in your digestive system, your gut, will increase the absorption of calcium ion into the bloodstream. So these three effects will help increase blood calcium levels, hopefully back up to homeostatic levels. And once you're back up to normal, the body's back up to normal, the parathyroid hormone no longer will secrete, the parathyroid gland will no longer secrete parathyroid hormone because the stimulus to secrete it's been removed by getting blood calcium levels back up to normal homeostatic levels. Okay? So notice the parathyroid hormone works in the opposite fashion as calcitonin. Calcitonin is secreted when you have too much calcium in the bloodstream. Parathyroid hormone is secreted when you have too little blood calcium. Too little blood calcium levels, or too little calcium in the blood, calcium ion in the blood. All right? Okay, next one. Excuse me, the thymus. Just superior to the heart and posterior to the sternum, breastplate. Notice in the fetus, it is bigger than in the adult. In the adult, it's essentially a residual organ. It secretes a hormone called thymosin, and that's important in prodding along the maturation of a white blood cell lineage called the T lymphocytes, and we'll talk about that when we do the immune system. So important in the development of the immune system. Excuse me. T for thymus, meaning T lymphocytes are lymphocytes that become mature, immunocompetent because of the thymus. So, overall immunity function. Okay. All right, let's get to the adrenal glands now. Suprarenal, meaning above, superior to the kidneys. Renal means kidney. We talked about this a little bit in the autonomic nervous system chapter. So paired little pyramid-shaped organs above each kidney. Two distinct regions. The outer area, which is the adrenal cortex, which is going to be secreting its chemicals, lots of them. And then the inner area, which is the medulla, adrenal medulla. And that's secreting the epinephrine and norepinephrine in terms of the functioning of the autonomic nervous system. So two distinct regions. So let's look at that outer adrenal cortex. If you zoom in, it has some zones in it, 3 of them. The outer capsule is connective tissue capsule. And then just deep to it, you're going to have the adrenal cortex, which is with its 3 zones, or region. Zona glomerulosa, zona fasciculata, which is fairly big, and then the zona reticularis. And then in the center, of the adrenal gland is the adrenal medulla, and that's just shown a little bit of it here. So histologically, you can usually distinguish between the three zones of the adrenal cortex. Okay? So what's produced by the adrenal cortex? Over 24 steroid hormones from the adrenal cortex. We only need to know a couple of them. These are vital hormones. You can get severe dehydration and electrolyte imbalances, and that can result in death literally within a week. So the three zones: zona glomerulosa, fasciculata, and then deepest is the reticularis, zona reticularis. One way to remember them, the G and the F and the R of the zona glomerulosa, fasciculata, and reticularis, in terms of from superficial to deep. There's an old band called Grand Funk Railroad, or Godfather Rules. Right? G, zona glomerulosa; F, zona fasciculata; and then R, zona reticularis. Right? So outer, middle, and inner zones of the adrenal cortex. So the zona glomerulosa, the outer layer within the adrenal cortex, produces mineralocorticoids. Main one, the only one you need to know by name, is aldosterone. And they are called mineralocorticoids. Aldosterone is a mineralocorticoid because it helps control the electrolyte balance in the body and the bloodstream. So think of these electrolytes as minerals to help remember the name possibly, okay? Like sodium and potassium, and in doing so helping maintain water balance as well. Right? So the only one you need to know by name again is aldosterone, dealing with electrolyte balance, and normally if we're talking about electrolyte balance, we're also talking about water balance. So the overall effects on blood volume and blood pressure, because if you alter the blood electrolyte balance and or water balance, you're going to affect blood volume, and that affects blood pressure. Okay, the middle zone. Remember Grand Funk Railroad, or Godfather Rules, the middle zone, zona fasciculata. It produces glucocorticoids. The main one to know by name, or the only one to know by name, is cortisol. And notice gluco is in the name, so it regulates the rate of glucose synthesis and then lipid release from tissues, and lipids can get broken down into glucose to help maintain glucose levels in the blood and in the body. Okay? Helps the body respond to stress and tissue damage. Right? When you're under stress, cortisol is helping you produce glucose and breaking down some lipid reserves to maintain glucose levels. And if you have tissue damage, you need tissue repair. So glucose, as terms of the energy for cell metabolism, is important in tissue repair. Okay? Long-term stress maintains elevated levels of cortisol, and that actually does have long-term negative health effects. And then the deepest zone, zona reticularis, or Grand Funk Railroad, or Godfather Rules, inner deepest zone of the adrenal cortex, excuse me, gonadotropins are produced there. So think gonads, think sex organs in the sense of the production of sex hormones. So it helps support the sex drive in both genders, the gonadotropins. So the overall functions of the zones, if you can think salt, sugar, and sex. Salt in the sense of ion solute levels in the bloodstream. Sugar in the sense of glucose levels. And then sex in the sense of sex hormones that are regulating and maintaining the sex drive in the genders. All right? So moving into the adrenal medulla, the central portion of the adrenal gland, inner core. It's innervated by the sympathetic division of the autonomic nervous system, and in response to stress, it will secrete epinephrine and norepinephrine.